In this video, we will continue our previous lesson about liquid. At the end of this lesson, students should be able to define vapor pressure and boiling point, explain vaporization and condensation process based on kinetic molecular theory and intermolecular force, explain boiling process, and illustrate the relationship between intermolecular force and vapor pressure, and the other one is vapor pressure and temperature. Vaporization. Okay, what is mean by vaporization? Vaporization is a process in which molecules escape from liquid into gaseous state through a surface. Vaporization occurs in two ways, which is number one, evaporation process, and number two is boiling process. Vaporization process is a process in which liquid is transformed into gas. Based on kinetic molecular theory, molecules in liquid move quite freely because we already know that the molecules in liquid are packed closely together but not in orderly arrangement. That's why molecules in liquids can move quite freely. When temperature is higher, average kinetic energy molecule increases and their molecular motion also increases. When the kinetic energy is sufficient enough to overcome the attractive force that bind them, molecules will loosen themselves and be evaporated off. This is the process of vaporization. Next, factor affected vaporization rate. So, we have three factors that affect the vaporization rate, which is number one, surface area, number two, temperature, and number three, intermolecular force. Okay, let's move to the first factor, which is surface area. The larger surface area, chances for the molecule to escape from the water surface increases, and so the rate vaporization will increase. Number two, temperature. At higher temperature, more molecule possess higher kinetic energy. So, more molecules have enough energy to escape from the surface of the liquid. Vaporization rate increases. Intermolecular attraction force. The weaker intermolecular attraction force, the faster vaporization rate, or the stronger intermolecular attractive force, the slower vaporization rate. Condensation process. Condensation process is a process in which gas is transformed into liquid. So, condensation process is the process reversed from vaporization. Based on kinetic molecular theory, some of vapor molecules may lose their kinetic energy during collision. As we know, in the gas phase, the molecules are far apart and in random motion, and these molecules collide with each other, collide with the wall of container or the surface of the liquid. So, the molecule do not have enough energy to remain as vapor molecule. When this molecule reach the surface of the liquid, and become trapped by the attractive force of liquid. If they cannot overcome the attractive force, these vapor molecules return as liquid molecules. The process is known as condensation process. Vapor pressure. Vapor pressure is the pressure exerted by vapor in equilibrium with its liquid in a closed container. Once equilibrium between the liquid and vapor is reached, the number of molecules per unit volume in the vapor does not change with time. This means that the pressure exerted by the vapor over the liquid remain constant. In an open system, vapor molecule which evaporate off will diffuse away, but in a closed system, vapor molecule which leave the surface cannot escape from the system. In a closed system, vapor molecules remain in the container and in contact with the surface of the liquid at the constant random motion. At this time, vapor molecules continually strike the wall of container, other vapor molecule, and continually strike the surface of the liquid molecules. At this time, pressure exerted, and this is called the vapor pressure. Okay, in the previous slide, we already learned about the definition of the vapor pressure and how the pressure is exerted. So now, let's discuss the relation between intermolecular force and vapor pressure. The stronger intermolecular force of liquid molecules, the greater kinetic energy needed for the liquid molecule escape from the liquid surface. Liquid with the stronger intermolecular force is less volatile because more energy needed to overcome the intermolecular force, and rate vaporization is lower. Since the number of vapor molecule is smaller, so it will exert a lower vapor pressure. So, from this point, we can see that a liquid with stronger intermolecular force will has lower vapor pressure. So, the liquid with the weaker intermolecular force will has higher vapor pressure. Boiling point. Boiling point is the temperature at which the vapor pressure of the liquid is equal to the external atmospheric pressure. This means that the boiling point of liquid depends on the external pressure. So, for example, look at to the value boiling point of water. At pressure equals 760 torr, boiling point of water is equals to 100 degrees Celsius, but at pressure equals 610 torr, the temperature boiling point of water is equals to 94 degrees Celsius. So from this information, we can say that when the pressure, external atmospheric pressure decrease, the boiling point of water also decreases. How about normal boiling point? So, normal boiling point is the temperature at which the vapor pressure of liquid equal to the external atmospheric pressure at 1 atm. Boiling point is a process of changes from liquid to gases that occur at the surface and inner part of the liquid. At this time, bubbles are observed, and temperature remain constant during the boiling process even heat is supplied. Boiling point only occur at specific temperature and specific pressure. Okay, now let's discuss the relation between vapor pressure and boiling point. Vapor pressure of liquid with a stronger intermolecular force are lower. This is because more energy needed for a liquid molecules to vaporize. So, at high temperature, it will increase the number of vapor molecule and exert higher vapor pressure. At this time, boiling point increases. So, from this point, we can conclude that a liquid with high boiling point will have lower vapor pressure, and a liquid with a low boiling point will have higher vapor pressure.